Hello all. In this video we shall learn about balancing of redox reaction. The balancing of redox reaction can be done in two ways. That is, first one is ion electron method and the second one is oxidation number method. In this video we shall be dealing with ionic electron method, balancing of redox reaction by ion electron method in acidic medium, and in the next video we will be dealing with basic medium. So today we will learn about acidic medium. Actually there is a redox reaction, it has to be balanced. How that can be balanced? It can be balanced in two ways: ion electron method and oxidation method. In which medium? Either is it acidic medium or basic medium. This is how it goes. So in this video we will learn balancing reaction by ion electron method in acidic medium. There are several steps and it is easiest step. I prefer ion electron method over oxidation method. So let's begin with step 1. It says produce unbalanced equation for the reaction ionic form. That means whatever the redox reaction you will get, here the question will be there will be a redox reaction, you have to make it in an ionic form, meaning to have a charges. So this is the question. Initially, usually they gave usually in the question paper they give directly the ionic form itself, that is these are the ionic form rather than the molecule. So second step, once we have written this, what is the second step? The second step is separate the equation into half reaction, that is oxidation half reaction and reduction half reaction. We all know what is a redox. Redox is nothing but redox reaction, that is nothing but that has reduction and oxidation taking place simultaneously. In this whole reaction equation we have to see which is redox reaction and which is oxidation reaction. As it is a redox reaction, the half of the reaction will be based on the reduction part, so it is called as reduction half cell, and half of the reaction will be based on oxidation, so it is called as oxidation half cell. So what is oxidation, what is reduction? We all have studied it in class 10. There is oxidation is nothing but loss of electron, whereas reduction is nothing but gain of electron. Now in a reaction, to identify which particular species undergo oxidation or reduction, just see the oxidation number. If the oxidation number increases, then it is oxidation number increases. If the oxidation number reduces or decreases, it is called as reduction. If at all, if it is an ionic form, let's say this one, Fe2 plus. What is the oxidation number of Fe2 plus? That is nothing but plus 2, positive 2 charge. Why? Because there is a rule in oxidation reduction method, that is ionic charge is equal to oxidation number. Now for a species like this, how to find the oxidation number of chromium? This is chromium. Now the question is find the oxidation number of chromium. How to find out? So let's take oxidation number of chromium as X. There are 2 chromium used, so 2X plus we have 7 oxygen, multiply each oxidation, general oxidation number of oxygen is minus 2, is equal to the overall charge is negative 2. So if you solve this, 2x plus 7 2s are, it will be minus 14, minus 2 is equal to negative 2 negative. So 2x is equal to minus 2 plus 14, 2x is equal to plus 12 and x is equal to plus 6. So if you see the reaction, first one, if this will be plus 6. Now Fe2 plus converts into Fe3 plus, 2 plus 2 3 positive, so oxidation number increases. If oxidation number increases, then it is oxidation. So this part is oxidation half reaction. Let's write oxidation half reaction, that is Fe2 plus to Fe3 plus. Now next let's see reduction. Here chromium plus 2, chromium in plus 6 oxidation state changes to plus 3. The oxidation number decreases. If it decreases or reduces, that means this is reduction. So the chromium plus 6 to plus 3 is an reduction half reduction half reaction. So it is Cr2O7 2 negative undergoes Cr plus 3. So we have got oxidation half reaction and reduction half reaction. So step 1 is get an ionic equation. Later on separate the both reaction into oxidation half cell and oxidation half reaction and reduction half reaction. Let's see step 3. Balance the atom other than oxygen and hydrogen in each half cell. So we have two half cell we have got oxidation half cell and reduction half cell. Other than oxygen and H, you have to balance other atoms. So here we have to balance Fe, we have to balance Cr. We are not supposed to balance oxygen. So in oxidation half cell, let's see what are the atoms present. Fe3 plus undergoes Fe2 plus. Both in left hand side, right hand side of the arrow, both Fe's are, one Fe is present. So balancing is not required, it is already balanced. Here reduction half cell Cr2O7 2 negative undergoes Cr plus 3. So right now oxygen we are not supposed to balance, we have to balance other atoms. Here we have chromium 2, so we have to balance this side as 2 chromium. So now both the half reactions are balanced. Let's see step 4. Step 4 is, now we have balanced, other than oxygen and hydrogen, we have balanced all the other atoms. Now once we have balanced all the other atoms, we have to balance now oxygen and hydrogen. Let's see how it goes. Step 4. For a reaction in acidic medium, now we are talking about, as we are talking about acidic medium, let's see how oxygen and hydrogen are being balanced. Oxygen are balanced, we have to add H2O to less number of side of oxygen, and we have to balance H to add H plus opposite to where H2O is added. You have not understood, I will tell, but always first balance oxygen, then balance hydrogen. First let's write the oxidation half reaction, that is Fe3 plus gives Fe2 plus. Here oxygen or Fe2 plus to Fe3 plus. Here oxidation hydrogen is not there, oxygen is not there, not required to balance. Next we have Cr2O7 2 reduction half reaction to 2Cr plus 3. Now if you see, we have to balance oxygen first. We have 7 oxygen, so we have to add hydrogen towards the opposite side towards the less side. So this side we have less oxygen, so we have to add hydrogen where there is less oxygen, and we have to balance it. We have 7 oxygen, so we will multiply 7 here. Now next, as now oxygen is balanced, both the side we have 7 oxygen, here we have 7 oxygen, here also we have 7 oxygen. Next we have to balance is hydrogen. We have to add H plus opposite to where H2O is added. Now let's add H plus. Here how many H is present? 7 into 2, we have 14 H plus. So add 14 H plus. So if you see both the side, the hydrogen, the chromium is balanced, the oxygen is also balanced, and hydrogen is also balanced. Let's see step 5. To balance the charge, now we have to balance this 2 plus 3 plus charges. We have to balance the overall left hand side, right hand side, such that in the left hand side and right hand side charges must be same charges. So let's see how it goes. First let's see what happens in oxidation. How oxidation is Fe plus 2 to Fe3 plus. Now here we have plus 2 charge, here we have plus 3 charge. This charges must be equal. Both the side, left and right side of the arrows, the charges must be equal. So how to equalize this? Just add 1 electron. So it will be 1 electron means it gives negative charge here. So what happens to this overall? Plus 3, this happens plus 3, and electron gives negative charge, minus 3. So total it is plus 2. Now both left hand side and right hand side, the charges are equalized. So we have added here, what we have added? Plus 1 electron. I will repeat again. First write the charges, first write what the charges are present. Here plus 2 charge of this thing, and here plus 3 charges we have. Both left and right side of the arrow, the charges must be same. Now the charges are not same, so we have to make it same. What we are supposed to do? The only method to balance the charge is adding electron. Electron gives minus charge always, because electron is a negative charge, it gives minus. I can't add electron here. If I add electron, what happens? Electron gives negative charge. Plus 2 and minus 1 becomes, it will be plus 1. That time the charges will not be equalized. So we have to add towards the right side of the arrow. I have added 1 electron here. So it will be 3 minus 1 plus 2. Hope it is clear. So we have 1 electron we have added in this reaction. I will erase all this so that for the better understanding. Next, reduction half cell. Let's see reduction half cell, what happens. So the reaction of reduction half cell is 14H plus Cr2O7 minus gives 2Cr3 plus 7H2O. 14H+. So 14 and H+. So it is charges plus 14. Here we have minus 2 charge over left hand side. Right hand side we have 2 into 3, it is plus 6 charge, and overall hydrogen has 0 charge. So here we have plus 12 charge and plus 6 charge. We have to, the both left hand side and right hand side, the charges are not equal. We have to equalize. How we can equal? We can multiply, we can add electron here, 6 electron we can add, such that what happens? Plus 12 and electron gives negative charge, so minus 6, it will be plus 6. That time left hand side and right hand side both will be equal. So I'll add electron towards left hand side, 6 electron. Hope this is clear. Step 5, balance the charge by adding electron. Let's see step 6. Add the two half reactions. Now we will add oxidation and reduction half reaction to achieve the net cell. Now we want net redox cell by adding both the cell. Remember always, redox reaction will never show electrons. So we have to multiply. See, now here we have 1 electron, here we have 6 electron. We have to cancel this both the electron. In the redox reaction, electrons are not present, so we have to cancel these electrons. Multiply. See, I have to cancel this electron and this electron. Both are in opposite side. I can cancel out. So how to cancel it? Just by multiplying 6. It will be 6 electron. This is also 6 electron. I can both cancel out. That is what step 6 is. Add the two half reaction to achieve the overall reaction. Cancel the electron if required. Multiply the specific number. Here we have multiplied 6. To get the equal electron on both the side and then to cancel each other. This gives a net ionic reaction. So let's add both the cells. First is oxidation reaction. Oxidation reaction we had Fe plus 2 gives Fe plus 3 plus 1 electron we had. And reduction half reaction is 14H plus Cr2O7 minus. Then we had plus 6 electron gives 2Cr3 plus 7H₂O. Let's add the whole reaction. Before adding, we have to cancel these electron. This can be cancelled if this electron is also 6 electron. So what we are supposed to do? We will multiply this whole reaction by 6. So it will be 6 F2 plus 6 Fe3 plus and 6 electron. In that way I can cancel out this and this electron. I can cancel this electron and this electron. Now you can add. So net overall reaction will be 14H plus Cr2O7 2 minus plus 6 Fe plus 2 gives 6 Fe plus 3 plus 2 Cr3 plus 7H₂O. In this way we can write the whole reaction. Just then afterwards, the last step, verify that the net equation contains same type of number of atoms and the same charge on both the sides. Now let's just verify it. We have 14H plus over left hand side. 7 into 14, we have 14 hydrogen. We have 2 Cr, here also we have 2 Cr. We have 7 oxygen. 7 into oxygen, we have 7 oxygen. We have 6 Fe plus and we have 6 Fe plus. This we have seen the atoms are same on both the sides, same type or number of atoms are same. Now let's see charges. That we are verifying. We have 14 plus 14, we have minus 2, 6 into 2 is plus 12. Next we have 6, this side we have plus 4 into minus 2 is plus 12, plus 12 and plus 12 we have 24 charge this side, plus 24 charge. Let's see right side how many charges are there. 6 into 3 is plus 18, 2 into 3 is plus 6 and here we have 0. 6 into 8 is plus 24 charge. So both the charges are equal. That means this is the net reaction has been verified and this is the balanced redox reaction. This is the balanced net redox reaction. Hope it is clear. In the next we will deal with how in using ion electron method how a redox reaction is balanced in basic medium. Hope you all liked it. If you have any queries, comment down below. Thank you.